Well, our question, as you have seen, is the being 1st of October 2024. So show that cosec of theta into 3 sine 2 theta plus 4 sine cubed theta is equal to 4 plus 6 cos theta minus 4 cos squared theta. So you're supposed to show that. That should be 3 marks, as you have seen. So this is how we proceed. First, we remember that cosec of theta is similar to 1 over sin theta. That is this. We want to rewrite it in a different form so that we get this. And we also remember here that sine of 2 theta is equal to 2 sin theta cos theta. So having those two identities, this and this, then it is possible to rewrite this in this form. So I have 1 over sin of theta into 6 sin theta cos theta plus 4 sin cubed of theta, like that, plus 4 sin cubed of theta. So I have this and I have this. Now we see that if we were to divide every term by sin theta, then I get here 6 cos theta. This divides this and I get plus 4 sine squared theta. That's what I have. Plus 4 sine squared theta. So I need to rewrite this. I need to rewrite this sine squared theta in the form of cos, because I have this. So that will mean that I have 6 cos theta plus 4 into 1 minus cos squared of theta. Since sin squared of theta plus cos squared of theta is equal to 1, that's an identity. So here we say that where sin is, we write this. Then open up the bracket and we see that that should give us 6 cos theta plus 4 minus 4 cos squared of theta. So in this form we have 4, that then implies that 4 plus 6 cos theta, 6 cos theta minus 4 cos squared theta. And that's the answer. That's the answer. And that's what you're expected to do. So that takes care of part A. So part A is taken care of. Part A is taken care of. So I move to part B. Part B says, solve the equation cosec into 3 sine. Actually, it's just the same equation we had before that we have just concluded, except that now we are adding 3. We are adding 3 to it. So I'll use this result, the result that we have here. This result that we have there. So if this is this, then what I can then do is say that 4 plus 6 cos theta minus 4 cos squared of theta plus 3 is equal to 0. Plus 3 is equal to 0. And we are told we need to do that within the limit negative of pi to 0. Negative of pi should be negative 180. So yeah. So that's what we have now. We can then collect like terms and have minus of 4 cos squared plus 6 cos theta. I have minus of 4 cos squared of theta plus 6 cos of theta plus 7 is equal to 0, because I'll be adding this 4 to that 4. Then I say let u be cos theta, because now I want to solve. Then I'll be having minus 4u squared plus 6u plus 7 is equal to 0. Plus 7 is equal to 0. And I can write this as 4u squared minus 6u minus 7 is equal to 0. Now this I can only solve because we should get two numbers whose product should give us 28 and sum gives us negative 6. And we don't have such numbers. So what we do is we use a quadratic formula. So quadratic formula will be having u is equal to minus b plus or minus 4 plus or minus b squared minus 4ac all over 2a. That's the quadratic formula. So if you apply that formula, if you apply this formula to this, so in our case, we are our A in our case is 4. B is negative 6, and C is negative 7. Now, if you substitute these values into this quadratic formula, then you should get the value of u as you should get as it's either 2.2706, 2.2706, or the other value you are going to get, because it's quadratic, you are going to get two roots. The other value is negative 0.7706875. So these are the values you are going to get. But we need to note that since we have these two values, and we know that the domain of the inverse cosine, because realize that u is equal to cos theta. So we are going, for us to get u, we are going to get the cos inverse of theta. So we need to note that we have two values, 2.2706, then 0.77068. But since the domain of the inverse cosine function is limited to values between -1 and 1, then it implies that the only value we can take between this and this is this, because the arc cosine is limited within the range of -1 and 1 inclusive. -1 and 1 inclusive. So we pick this as the answer. Now, if that's the answer, then what is we are asked to get the value of theta, so we are not done yet. So theta, we work theta out as. So what we have is that u is equal to negative of 0.770685. That's u. But realize that u was equal to cos theta. So what we have here is that cos theta is equal to negative of 0.770685. That should then mean that theta is therefore the cos inverse of 0.770685. The cos inverse. Yeah, the cos inverse of that. So the cos inverse of that, if you find the cos inverse of that, if you get it, it should be close to, this you press straight away from your calculators, and you'll get the value 2.448 radians. 2.448 radians. 2.448 radians. That is theta. 2.448 radians. But since the requirement is that our radians should lie between negative of pi, actually it is greater than negative of pi and is less than 0. So here, having this 2.448, we make it negative 2.45 radians. And that's it. That's it. Okay, that's that. So I need to move to part C. Part C of the question. Part C of the question. Part C of the question, which is asking us. Part C of the question is asking us. Part C of the question is asking us to integrate. That's the integral of 4 plus 6 cos theta minus 4 cos squared theta, yeah, d theta, that's what we have. So we can see that it's of open limits, and if that's what we are required to get, then we start by saying our first scenario will be we integrate each term. We see how each term will look like. So it is 4 d theta plus 6 into cos theta d theta minus 4 into cos squared of theta d theta. Did I miss something? Yeah, it's just like that. It's just that. It's 4 plus 6 cos theta minus 4 squared. Yeah, like that. So here we have, if we integrate this, it's going to be 4x. It's going to be 4x plus c. That c is a constant. And if I again come here, if I again check here, I'm going to have, because the integral of this is sin theta. So the integral, if you integrate cos theta d theta, you get sin theta. So I'm going to get sin of theta plus c, but again, I leave it as such. Then I come here, minus of 4. So I'm integrating this part. Then I'll have cos squared theta d theta. We say but the integral of cos squared theta d theta, let cos squared theta d theta. Now we let see but cos squared theta d theta. So what we do to make our work easier, we need to rewrite this part. We rewrite this part. So rewriting that part will mean we can make use of an identity. We had 2 identities that we had written. I must have rubbed them. Yeah, but there were 2 identities where we can represent this in a different format. So how do we change it? We know that cos of 2 theta is equal to 2 cos squared theta minus 1. That's an identity. Cos of 2 theta is equal to 2 cos squared theta minus 1. So, and because I want to rewrite this, it then means that I will make cos squared theta the subject. So that should imply that 2 cos squared theta is equal to cos of 2 theta plus 1. And that simply means that cos squared theta is equal to cos of 2 theta plus 1 all over 2. All over 2, like that. So it means that where there is cos squared theta, I can write all of this. Cos 2 theta plus 1, I can write cos 2 theta plus 1 over 2. So I'll rewrite this. So I say but the integral, rewriting this will be but cos of 2 theta over 2 plus cos of 2 theta over 2 d theta plus d theta plus a half d theta. So this for consistency, I could also just say this so that I have a half here. So that I have a half here. Yeah. So our problem reduces to this. But of course, the other part we can straight away tell. But this part, how do we go about it? So we say half of cos 2 theta d theta is given by, that is half cos of 2 theta d theta, cos of 2 theta d theta is given by, here we apply chain rule. Now we apply chain rule. We apply the chain rule. Apply the chain rule in that case. And the chain rule is dy dx is equal to dy du dot dy du dot dy dx is equal to dy du dot du dx dot du dx. Yeah, that's the chain rule. So chain rule is change in y over change in x. This is d. I think it should be clear. These are d. Yeah, that. So we take our case and say let u be 2 theta. Let cos u be 2 theta. So if u is 2 theta, then if we have let our u to be 2 theta, then what we are saying is that du the theta is equal to 2. And the integral of cos u, so this should imply that the theta is equal to, because that now will be 2 d theta, du is equal to 2 d theta. Okay, what do we have? So if we have that 2 d theta is equal to du, that implies that d theta is equal to du over 2. So what I will have is that I already have cos u here, but where there was d theta, now I should write du over 2. So that becomes du over 2, like that. Du over 2, like that. So it's cos u du over 2. That is, that's what I have. And this should give me half into sin of u plus c, half of sin of u plus c. That's what I get. But then I need to combine it with, I need to combine this and that. I need to combine this and that. So that means that dy dx will be equal to dy du dot du dx, which is equal to dy du. Now we get this as half into sine of u plus c, half into sine of u plus c. Then multiply again by 2, because we have this 2, and that gives us sine of u plus c. That's what we get to be this part. But realize that we had a 4 here, which we didn't take care of. We had a 4 there, which we didn't take care of. So it means that we can rewrite the entire part as minus 4 into sine of u plus c. That's what we would have finally as that. But that's not all. So let's see how we finalize this. I'm already here. I've written up to here, so I can only conveniently wrap this part. No, this part now, I'll leave it as such. So we are already up to, what we had wanted was this. So I said we needed this, and that is this, and then the whole of this gave us this, gave us that. Then the whole of this, actually this should be 4. This is not x, because we are dealing with theta here, so this is theta. So 4 theta plus c. And then the whole of this gives us sin u plus c. The whole of that gives us sin u plus c. So we can combine the results. If we combine the results, because now it was this plus this minus that, if we combine the results, what we get is is, so I start with this. So I call it okay, part C, we have the integral, because we are using the result that we have just had in part B, will be 4 plus 6 cos theta minus 4 cos squared of theta d theta. That's what we have. And we can see that we can get the integral of 4 standalone, this standalone, but that we need to rewrite in a different form. And the identity we are going to use to rewrite it in a different form is that cos of 2 theta is given by 2 cos squared of theta minus 1, implying that cos squared theta is equal to 1 plus cos of 2 theta all over 2. So that's how we are going to rewrite this part. And then means that we have 4 plus 6 cos of theta minus 4 into 1 plus cos of 2 theta all over 2 d theta. That d theta, like that. I can straight away divide this so that I have here minus 2, this minus 2. Because divide so that I have that minus 2. And if that is the case, then if I open up the inner bracket, then I end up with 4 minus 2, which is 2. So it becomes 2 plus 6 cos theta minus cos 2 theta d theta. D theta, like that. So I want to consider the integral of each term. That is this term, and that term. So I start with the first one. 2 d theta is equal to 2 theta plus c. That's this. Then the other one is that 6 of cos theta d theta is equal to 6 sin theta plus c. It's going to be 6 sin theta plus c. But now we have this part here. That's what we want to spend time on now. It will be, that part will be, but the integral of cos 2 theta d theta, we say let u be 2 theta. Therefore, du d theta is 2. Du d theta is 2, implying that d theta is du over 2. Then because we have that to be u, then we say, but the integral of cos u, where there's d theta, we put this, du over 2 will be the same as half into the integral of cos u du, which is half into sine of u plus c, as such. That's what we have, it's half. So if yeah, it should be minus this because there's this minus 2, then this is minus 2 cos minus 2. We have here minus 2. Yes, minus 2 cos 2 theta. So because we have this integral, we were getting that integral, definitely this 2 will cancel that 2. And so it means that what I will have as the integral is if this half multiplies this, then it becomes sin of u plus c, sin of u plus c. So bringing them together is 2 theta. Now the c's are the integration constants. If we applied the limits, then they'll be cancelling out. So we can omit them. We can ignore them for now because they cancel out anyway, those c's. So I just pick the first part, which is 2 theta plus 6 sine of theta minus sine of u minus sine of u plus c, because the constant has to be there somehow at the end, because we are not applying the limit. So one constant will suffice because it's it's under one integration. But we see that u was 2 theta. So we write it as 2 theta plus 6 sine of theta minus sin of 2 theta plus c. And that's our answer. So that wraps up that question. That is the Pato logarithms. I urge you to go through them, through the steps carefully, while noting the different identities that we have employed to reach the answer. Up to there, thank you, and see you in my next video.